how to use our integration
Okay.
tables worksheet and such?
In the designated spot.
Wait, so I need to go
I
find
really
this
don't
again.
love when.
You take this test.
Yeah, group ten.
Oh, we don't have to grade one then?
At least like.
Sounds mighty appealing.
Go back to the.
So, questions, so we did the odds and review A were due today. The evens we will assign today. Tuesday, the odds from review B will be assigned. Wednesday, the evens from review B, which is still, that's still plenty of work, because as you can see, these have some good mass to them. Thursday, we will just review in class. I'm not gonna give a new assignment, so you can enjoy your break. You have certainly earned it. Friday, we will take this semester final, and then that'll put a wrap on our first semester. There's still, I'm struggling with the topic questions, getting on there. I think that's College Board's issue. I try to get on there, so, but it's rejecting me at this point. But I think there may still be some grades out there on those topic questions that I have to get. We'll go on and start on new stuff in January. I'll have to decide. I don't know if I'm gonna count any of that or not. I may just, I think we have a lot of grades already, so I may just count even the homeworks and all that stuff as the start of semester 2.
The
So
final will be started?
after the final.
Oh, okay, I was like, okay.
We need to report.
Yeah.
One grade.
So are there, does that make sense how, what the plan is? So we're taking the final on Friday at 8 again in our favorite testing location, cafeteria. So any questions, ones you'd like to see clarified from review? Yes,
Can we go over 6?
number 6.
Oh,
Yeah, these are always hard ones. So, we have z cubed is equal to, z cubed minus a equals 0. So this problem can be kind of posed a couple different ways. In this case, I just said solve this. I might also, because if you added the 8 to the other side, it could have been phrased as find the cube roots of 8. So those two questions are equivalent to each other, whether you're just finding the zeros of this, all the solutions, or finding all the cube roots of 8. So we're gonna get 3 of these. There's gotta be 3 cube roots. That's part of the fundamental theorem of algebra. So what we wanna do is turn this into a complex numbers issue. And so we're gonna think of our variable z as being r cis theta. So we don't know what it is. So, but this variable, this z we're looking for, the cube roots of 8, are gonna be in the form r cis theta. So we're gonna have to figure out what the r is and what the theta is, and again, we're looking for 3 of them total. So we want to then also know what the cube root of, so we're gonna say, if I plug this into this equation, we're gonna get r cis theta cubed is, I'm gonna add the 8 to the other side. So we want to write this then in cis form, and we're gonna come back and write this in cis form as well. So when we cube this variable that's in our polar form, we're gonna get r cubed, and then that's gonna become cis 3 theta. Remember that from our theorem on that, de Moivre's theorem. Then so now the left side is written in polar form, but the right side is still written in rectangular form. So we need to convert that 8 into its own r cis theta. That makes sense? So I like to think of it just, visually, graphically. You've got the reals here and the imaginaries there in our Argonne diagram. And so the 8 is going to be on the real axis in the positive direction. So it's going to be out here at 8 on the real and 0 for the imaginary. And so we want to think of that in terms of what is its r and what is its angle theta. And so the r being the distance from the pole, so that distance is gonna be the 8, so our r is gonna be the 8. And the theta, because we're right on the x-axis, is gonna be an angle 0. And so we're gonna think of that as being 8 cis 0. This is the part I think that the hardest part right here, is just the getting started part, is how in the world do you get these to be consistent, whether they're both in the same form. Because if you start trying to solve it up here, and one of these is in polar form and the other is rectangular, you're in trouble right from the get-go. So now what we get to do though is, the only way these can equal each other is if their r's are equal, so the r cubed must be equal to 8. Now, because of the way, the angles work with sines and cosines, the 3 theta could be equal to 0, or it could be some multiple of 2 pi plus 0. And since we know that there are gonna be 3 solutions to this, 3 cube roots, we know that we can only get 3 different values here. And so we're gonna say k is gonna go 0, 1, and 2. I mean, we could keep going, but we're just gonna keep circling back and getting the same answers over and over again. There's only gonna be 3 distinct answers to this. And if we let k go beyond 3, we'll just get repetitions of ones we already have. So the r here then is gonna be 2. And we divide through by the 3, and so we'll get our theta is gonna be the 0, and then we're gonna get 2 pi over 3 times k is the way I'd like to think of that. K going again from 0 to 1 to 2. And so that, the different values of k giving us the different multiples of 2 pi over 3 are gonna give us the different actual numbers.
But I'm sorry, how did we decide what K could be?
K is always gonna, well, we kind of decide in advance how many solutions we're gonna get.
Okay.
And because of the fundamental theorem of algebra rather, we know that any polynomial degree 3 will have 3 distinct
Oh,
roots.
right, okay.
And so that's how we knew going in that there was gonna be 3, because it was cube roots, or, I could have asked the question this way. So that's gonna determine how many there are, and then we'll just start at 0 and go until we get to the right number of different possible answers.
Awesome.
And so then our first solution is gonna be 2 cis, and we're just gonna plug in the 0, and so it'll be just 2 cis 0. And the Z2 is gonna be 2 cis 2 pi over 3 times 1, and the third one will be 2 cis 2 pi over 3 times 2 is 4 pi over 3. So these are not nice numbers, and I would probably just stop it here, but we know those values, so then it's a chance to then show that we really do understand what cis means, and it means cosine of theta plus I times the sine of theta. Yes?
So if we chose not to do that, would our answer still be considered correct if they were all
No,
X's?
I will probably say give me the rectangular form of the answers. In which case that would be stopping short of getting all credit for that one. Even if you did, should have earned extra credit on the last test.
Because that's worth a shot.
Oh, it's always a negotiation. So cosine of 0 is 1, sine of 0 is 0. So that's our real answer, the one we could have gotten. And that's the algebra 2 answer, right? The pre-calculus answer is, oh, cube root of 8, easy, that's 2. Now you know more, so there is more. So now we get then 2 cosine of 2 pi over 3 plus 2I sine of 2 pi over 3. So cosine of 2 pi over 3 is going to be, nice, so that's going to be 2 times a negative 1/2. And the sine of 2 pi over 3 is going to be, so our final answer is going to be a negative 1 plus I square root of 3. So there are the first 2 cube roots of 8. And then we'll get 2 times the cosine of 4 pi over 3 plus 2i times the sine of 4 pi over 3. And the cosine of 4 pi over 3 is negative again. And the sine of 4 pi over 3 is also negative, because now we're in quadrant 3. And so we'll get a negative log minus I square root of 3. So there's the symmetry. I mean, if you were to graph those, we would have gotten 2, and we'd have gotten, that would have been a distance of 2. So these are all gonna be on a circle of radius 2, and they're gonna be evenly spaced. And there's 2 pi over 3, there's 4 pi over 3, there's 6 pi over 3.
I just draw that on my test and come up with that.
Oh, yeah, that should score well.
Okay.
Okay. Questions on that? What's
Yeah,
that?
you're just like, oh, radius 2, boom, and then I know that they're like,
If you have a real solution, then you can always derive it from a circle, because the real solution is gonna be a radius, and you can just graph that point, and then you gotta just put all the points for the others,
and it's cute, so
and then
like
use
there's
like fancy
3.
math to figure out what the other ones are, so it's like all.
Can you take like sines and cosines of imaginary numbers?
Can you take sines and cosines of imaginary numbers?
I guess.
Stop getting ideas.
Just real numbers.
Yeah. I think that's out of the domain.
Okay.
Yeah, yeah, I think it's a real, this domain is real numbers, actually. Not that I'm aware of. But we'll see in this class, well, we'll see that Euler's theorem, which is crazy, because you can take an exponential. You'll see that. So you can take an Euler's number raised to an imaginary number, and it crazily enough comes back to sines and cosines.
Wow.
Or who would
I'm not
ever,
invented
who
one.
That's
thinks
cool.
of this stuff? Euler. Yeah, it is cool. And you'll see why.
Where do I get my name
Now
on
that
it?
Euler's like discovered.
Yeah, Euler's got his name on it. This stuff is pretty legit. Anything else? What else would you like to practice? Anything to get the rust off?
Yeah,
Vectors?
No.
but you don't know the
Because
cross
otherwise
products, all
I'm in
that funny
trouble.
stuff that we were supposed to.
Dot products and cross products?
Converting from
whatever those-
polar into rectangular and dot
Everything that I was supposed to learn about.
converting from polar and rectangular.
So,
Or just the stuff that will be on the test. If you wanna only do that, that's okay too.
Yeah,
just
no,
narrow it
yeah.
down a little bit.
That'd be helpful. Or what's bracket size? Yeah. I would move my vectors in there. That's a little one that I like.
Oh, it was okay there for a second.
Something like this?
Anything that I'm supposed to know about.
And it doesn't, well, this isn't quite the dot product.
Oh, that's okay.
Is it okay? Okay, give it a shot. Those that are willing and interested can do it at the board, those that.
I just like to be up at the board because it gets easy to talk.
Yeah, it's fine. Vector AB. I believe in you, Cameron.
You know what, can I get you guys, let me have you do this. Katya, can you work over on that side? I think for me to post the videos on YouTube, I can't
Couldn't find it like that. Remember?
images of
Tips the tail.
Well, it is
something over here, yeah, probably screwed it up already. Why is it following you? It's like smoke following beauty there.
No, it's cute. It doesn't like it.
So if I can get away from you, rather.
I got negative 6, 2, and 4. Okay, now we need to find the midpoint. And so we found the midpoint by dividing them all by 2, I think.
And then it's just like,
The midpoint would be negative 3, 1, 2.
sorry.
Okay. The plane perpendicular. I remember how to do this one. That's the one where it's like negative 6x plus 2y plus 4z equals d.
What's that?
And then you plug in points.
Yes, then we plug in.
I don't know. Let me. I actually want to write it with midpoint.
So midpoint is the average of the x, y, and z. Add them divided by 2.
And we plug in the middle.
So if you add these divided by 2, add these divided by
Wait,
2.
no, he's talking about adding.
That's the midpoint.
He said he talked about adding. Yeah, that's what I did. Cameron, we were mistaken.
18 plus 2 plus 8 equals.
Cameron, we were mistaken. The midpoint is not what we originally believed.
I did that first.
We have to add them together.
But we need to find a point. The midpoint. That would be the easiest one.
That's
Yeah.
fine.
I think you need that,
Yeah, but that?
That's the midpoint.
So negative 2.
Oh.
So did you get negative 2, negative 1, 2?
Oh, okay, this is the second, right?
Yeah.
So then it's like -6.
Because that's how you
So
found
that
it.
is your normal vector, yeah,
So
you're
then
right.
the numbers, the vectors like become coefficients of the equation.
Oh, because
And
it's
then
Yeah, and then I'm
like.
pretty sure, if I'm not mistaken,
So that's like negative 1, 2. Okay, so now we do your thing where we write.
yeah, but we write the equation with the vector.
So vector AB, since our plane is perpendicular to the vector is perpendicular to the plane.
Yes.
It is, the vector AB is our normal vector for the plane. It's gotta contain the midpoint.
We write our plane equation, and then we plug in the midpoint to find out what d is, and that'll be our final answer.
The B is farther out.
Yeah,
But
it's
that's
the
just a
first, it's the
constant.
second one.
It-
Second one
You
has
could
the
use,
first,
you could use any of the constant.
Grace, is it a positive 2 for the y component?
You know what?
Yeah.
It is.
Because you're gonna go tip minus the
I
tail.
did it, Cameron, I'm all done. Yes, I did, all by myself.
Now I think we're good.
There we go. Okay, now I just plug this my constant.
Then we evaluate at the midpoint.
Why is the black the north?
And I got what they do. Okay, so we'll have to remember that, if the midpoint is adding, not subtracting.
Green, can you like draw me, like I can follow the steps, but like,
Plus 14.
so there's, can you start off with like the vectors by
Yeah,
the?
yeah, we do. So we're in space,
Right.
vector AB. We'll say we're going from A to B. We're gonna find its midpoint.
Oh,
Yeah.
Now we want to take that plane that's gonna slice under there perpendicular.
is that the equation?
So I'm gonna
No,
grab,
because the vector, just by
so
using.
we've got our vector. We want that plane that's gonna go through the midpoint. Well, because the plane is perpendicular to the vector.
No, my arm's too
The
sore.
vector's also perpendicular to the plane.
So last night we made types of it.
So it's really our normal vector for the plane.
Feels like
It's because
squishy
it's
buttons.
the entire
So our equation of the plane is ax plus by
I don't understand.
plus cz equals d, where the a, b, c, we call that normal vector to the plane. It's any plane, it's any vector perpendicular to the plane.
But there's like normal, or there's like numerous ends though, right? 'Cause you could have like one over here, like one over here.
Because remember, a vector's movable. So it's the direction that's its key, because it's, the direction is pointing, and where it starts and ends is really not, because vectors can be considered movable. So whether it's coming through the midpoint, it's that,
So like this one's the same as this one?
yeah, exactly,
Got it.
okay. And then we need a point, so the X, Y, Z is gonna be our midpoint.
Yep, okay.
And so when you plug that in, then we'll get the D.
Cool.
Seven
Thank
plays,
you.
You are welcome.
6 times. And the guys
So it looks like we are reaching consensus, well, we aren't either.
I was thinking about that.
So I got one version that has negative 6x plus 2y plus 4z equals 18.
Yeah.
Okay, but then you gotta do it out of the 18 also. You can't be selective in your division.
They have a root of 7 plays. I don't know, that's a good question. Oh yes, looks like you can. The iPad following.
Same way.
It's kind of spooky.
Okay, we ready for a new one? 4-minute question.
What? They already do, yo, the vaccines, man, the microchips.
Oh.
Wait, I remember how to do this.
Oh, don't we do the?
It's 1/2 AB
It's hilarious.
sine theta.
I don't know.
Because it just,
What's ABAC?
that's the magnitudes of those. I don't know, I forget how to find the magnitudes. Mr. Sir, how do you find the magnitude?
It's the square root of.
Oh, that's right, it's the square root of all of them added together.
Yeah.
Okay, I remember now. Never mind, we're good. Cameron, solve it
So you
with
find
AB.
vector AB and vector AC.
So the magnitude vector AB. First we find the
Two,
vector.
-2, -1,
Or what were you thinking?
And then the absolute
and
value.
AC
Yeah, yeah, we'll do that.
-1.
First you gotta get the vectors to put in there. So you need, because you need vector AB and vector AC.
Okay, so now the magnitude of one.
Then you'll get us cross product. And then get us magnitude. And then divide by 2.
No, they're times each other.
So then we just go 2 square
Let's
roots.
find the sine of theta first.
So you're gonna find a couple of vectors. They're gonna determine between them a triangle. So we know that if we take the cross product of those vectors, that the magnitude of that cross product vector is the area of the parallelogram formed by the two vectors. So if we take the cross product magnitude divided by 2, that's the area of the triangle.
was looking at.
Catch that, Dave? You wanna say it again?
I want you to
So
say.
you need a couple vectors with a common vertex.
What is your call?
A, B, A, C, B, A, B, C, doesn't matter. Then you're gonna take their cross product,
So pretty.
Oh gosh.
and you're gonna take its
It's a
magnitude.
minus
And divide that by 2.
What is, so like, I know, like the formula for cross products, but like
So
what
you
is
get
it?
6 minus.
Cross product of two vectors is the is the vector perpendicular to
9i
both.
minus
We talked about the right hand.
7j
So you take two vectors and cross them. You get a vector that's perpendicular to both of them
It's
Actually, I've never tried that.
at the same time.
plus.
So that's unique except for direction.
No, you're wrong.
Plus -7.
So you cross V
No,
with
plus 7, it's
you
not
cross
negative.
V, you go up, and
It's not negative.
yeah, well, V
It's
cross U
minus
would go
j.
down.
It goes minus and then plus.
So then how does
I
that
don't know, I'm kinda guessing.
Okay, so you
work with,
Like
like, how does that work? Tie
Oh,
into
yeah.
your-
So crazily enough, so you got these two vectors in space, and when
No,
you
we're not.
take their cross product, you get a vector perpendicular
Can I
to
have
each of them.
9?
It turns out the magnitude, the length of that cross product vector
We need to find the magnet, I
is
don't know.
the area
Stop. We need to
of
find
that parallelogram.
Oh,
So in a sense,
like that's just like a pattern?
yeah, so in a sense it has to do with, you know, how
Yeah, we did.
close
This
to
is not good.
collinear are they? Because if the two vectors were exactly the same direction, the cross product would be zero because there'd be no area between
I
them.
don't know.
The more they come close to perpendicular, then the bigger, the longer that vector becomes.
How do we actually find the area from?
Then it's the Pythagorean square root of a squared plus b squared.
Because that's just the area, or?
So that's the area of the parallelogram. The magnitude, the length of the cross product is the area of the parallelogram or the triangle.
Like, it's just that, like, it's one half, times 1 half.